Howdy! In this video, we're going to find the average rate of change of a function f of x from x equals a to x equals a plus h. In other words, we are deriving the difference quotient. So here's a random function shown in blue. We'll call that f of x. Okay, and we have 2 points marked on this function. The first one is at a random x value called a, so therefore its y value is just f of a. Second point is a plus h. So what we're doing is we're letting h be the distance between these 2 points, right? So if this is 0, the distance from there to there is a. Well, then if you add h more units onto that, you would be at a plus h, okay? So that's the second point, a plus h comma f of a plus h. Okay, so we want to find the rate of change of the function between these 2 points. Why? Because by doing it this way, it allows us to find the instantaneous rate of change down the line in calculus, right? So this is kind of an algebraic practice and setup for finding instantaneous speed or velocity later on, which the h notation helps us to do. Okay, so we're just going to churn through it here, right? So average rate of change is already, hopefully you already know or saw in a prior video that average rate of change is your change in your y values divided by your change in your x values. I'll just write it like that real quick. Change in y over change in x. Delta means change in. Oh, to come down here. Okay, so the change in y values. Well, the higher y value, or this, it doesn't have to be higher or greater, but the second y value is f of a plus h. So it's f of a plus h minus the first y value, f of a, all divided by change in x. The second x value is a plus h minus the first y value, which is a. Well, those a's do cancel, a minus a. And so what we get is, we call this the difference quotient. I'm going to abbreviate it right here as difference quotient. I like to call it DQ, which if you live in Texas like me, you'll get that. Um, Anyways, it is f of a plus h minus f of a all over h. And there you go. There's your difference quotient, okay? So that is definitely something you would want to have memorized for most pre-calc classes and definitely for calculus. Now, we're going to practice using that a little bit on a linear function and a couple of quadratic functions, okay? So let's start with this one. For f of x equals to negative 3x plus 4, we're going to evaluate and fully simplify. When I say simplify, let's clarify that here. When you're finding a difference quotient, you always want to keep simplifying until that h cancels, for reasons that you will learn later in calculus, right? But when it says simplify, to be clear on all of those, that means until the h and the denominator is able to cancel with an h out of the numerator. So it takes a little work typically to get there, okay? All right, so let's compute it. Okay, so we have f of x plus h. Let's call it dq. dq equals f of x plus h minus f of x all over h. All right, f of x plus h, that's negative 3 times parentheses x plus h plus 4. All I'm doing there is replacing this x by that x plus h, okay? We're plugging in x plus h right here. All right, so that whole piece there is f of x plus h. I'm going to just highlight that as f of x plus h, okay? Then it's followed by minus the function f of x. Well, the function f of x is exactly what we started with. So let's put parentheses because we are subtracting. The function f of x is negative 3x plus 4. Okay, or a lot of people like to just distribute the negative in their head and not write parentheses, which is fine also, just be careful. Okay, I'll do it in 2 steps though. All right, so next up, I'm going to do some distributing. So negative 3 times x, negative 3 times h, and then also distributing that negative. So we get negative 3x minus 3h. We have this plus 4 right here. Distributing the second negative, negative of negative 3x is positive 3x. And then that one becomes minus 4 all over h. All right, we're going to look for some things to cancel. They should always cancel, okay? So negative 3x will cancel with positive 3x, and 4 minus 4. There we go. Now, after all of that cancels, I'm going to rewrite it real quick, but you can see that then the h's also cancel because h divided by h is 1. So we also, for this, we just get a number, which is actually not common, but that does always happen for linear functions, right? The slope of the linear function is its average rate of change, which should make sense because the line has slope -3. So the slope between any 2 points is -3, right? We just proved that it's true for all values. Okay, that is not the case for quadratics. So next we have this x squared minus 4x plus 7, and then you can pause the video and try that one on your own. So on this one, we're going to evaluate and simplify the difference quotient. So that difference quotient is, let's write it out. You need to write it over and over every time you do a problem until you have it memorized. So f of x plus h minus f of x all over h. Okay, now pause and try this first because it's a little tricky. We're going to plug in x plus h into f of x. So if I plug that in right here, I'm going to have that turns into x plus h and that turns into x plus h. And so we get, let's see, parentheses. There we go, parentheses, x plus h all squared minus 4 times parentheses x plus h minus 7. Okay, that's just f of x plus h, right? It's different than f of x followed by a plus h tacked on to the end, right? We are plugging in x plus h into the function f. Okay, minus. Now we're minusing the entire function. Remember, we put parentheses because we are subtracting the entire given function, which is x squared minus 4x plus 7 all over h. Now, this will take a little bit of algebra, but it always works out the same, right? So when we FOIL x plus h squared, that's x plus h times x plus h, you're going to FOIL that out. First outside, inside, last. So first terms would be x times x, or x squared. Outside term is x times h. Inside term is also x times h. So that simplifies to plus 2xh. Last term is h and h. That h times h is h squared. Then here we distribute that -4 to get -4x minus 4h. Carry down the -7 there, and distribute that last -7 to get minus x squared plus 4x minus 7 all over h. Now, real quick, you cannot do this. Those don't cancel, right? The only reason something cancels from a numerator and denominator is because when you divide them, you get 1. But if the numerator's not factored, you can't peel h over h off as a multiple, as a factor of 1, right? So that doesn't work. So we have to factor first, then cancel. Before we can factor, we need to simplify. So look for terms that cancel. And if nothing cancels, or if not enough cancels, you've made a mistake. So x squared minus x squared does cancel. Let's see what else we have. We have -4x plus 4x. Oh, and I think I may have made a mistake here because my 7s are not canceling, but they should. And I do see the mistake right here. -4x plus 7. That should actually be plus right there. So this, I'll put it in red. I had initially called that a minus. That should be plus, right? But see, that's how I knew I made a mistake. It's because I knew they were supposed to cancel. Plus 7 minus 7, now they cancel. Okay, now everything you're left with should have an h in it every single time. It's kind of a cool thing about difference quotients. They work out the same every time. So I'm going to factor first, then cancel. Take that h out. Taking an h out of 2xh leaves us with 2x. Taking the h out of h squared leaves us with plus h. And taking an h out of -4h leaves us with -4. Okay, and then the h divided by h cancels. And then we have a simplified difference quotient of 2x plus h minus 4, right? So in practicality, you would plug in a number for h to find the difference, or how much does the function change, and x, actually, to find how much the function changes from x to x plus h. You plug in some values. This is like a shortcut formula for average rate of change, okay? And again, this gets built on in calculus to find what's called derivatives ultimately. Okay, last one, make sure that you do pause and try this one on your own. It's very similar to the prior example because it's also a quadratic. Main difference being it has a 2 as a leading coefficient instead of a 1, so you just have to be extra careful about that. All right, and again, write it every time. So the difference quotient, or DQ. I'm thinking of the Dairy Queen song. Anyways, f of x plus h minus f of x all over h. Okay, so f of x plus h, we're going to plug in x plus h into the function there and there. Each x gets replaced by x plus h in parentheses. So 2 times parentheses x plus h squared plus 3 times parentheses x plus h minus 1. There's f of x plus h. All of that. In fact, let's kind of re-highlight all of that is green. In green is the f of x plus h minus f of x. So open your parenthesis or just distribute the negative in your head. But I'm going to recopy 2x squared plus 3x minus 1. That is my f of x function right there, okay? Now we multiply it all out. Okay, so we have two, remember order of operations, exponents, PEMDAS. Please excuse my dear Aunt Sally, right? E comes before M, so exponents before multiplication. So we're going to FOIL this first before we multiply in the 2 to get x squared plus 2xh plus h squared plus, distribute the 3x plus 3h minus 1. And we're distributing that negative to get minus 2x squared minus 3x plus 1 all over h. All right, now let's look for things that cancel. So we have minus 1 plus 1 cancels so far, and a plus 3x minus 3x cancels so far. More will cancel after I distribute this 2. So let's do that. So that gives us 2x squared plus 4xh plus 2h squared plus 3h minus 2x squared all over h. There we go. And we're going to look for some things to simplify. Let's see, what else can we do? We've got 2x squared minus 2x squared. Boom. And everything remaining should have an h. If you have a term left at this point that does not have an h, then you have made a mistake and you need to go recheck your work. So now we can factor out an h. That leaves us with 4x plus 2h plus 3 all over h. And that h divided by h cancels, and we are left with 4x plus 2h plus 3. And that's our difference quotient. All right. In other videos, you can find difference quotients of rational functions and radical functions.